This video looks at the area and perimeter of a trapezoid. So what is a trapezoid? So trapezoid is a four-sided enclosed figure with at least one pair of opposite sides that are parallel. So this is trapezoid A, B, C, D, where I have four vertices. The vertices are where the sides come together. And I have four sides, and at least one pair of sides is parallel. These red arrows mean these two opposite sides are parallel. And this trapezoid could be called XWZY. It could be called XYZW. I've mentioned in previous videos that you can name an enclosed figure by going around it either clockwise or counterclockwise. So again, this could be trapezoid DCBA, trapezoid CBAD. Another one would be going clockwise, trapezoid BCDA, etc. Another name for a four-side figure that is enclosed, I should say it needs to be enclosed, is a quadrilateral, quad meaning four. So in previous videos I've talked about squares, rectangles, parallelograms, and triangles, but triangles don't actually fit in this categorization here because they have only three sides. All these figures have four sides. Well, remember the trapezoid is a four-sided figure. A parallelogram is a four-sided figure. A rectangle is a four-sided figure. And a square is a four-sided figure. Well, it turns out that the definition of trapezoid is the most general definition. It simply is a quadrilateral with one pair of sides that are parallel. Well, that fits the definition of parallelogram because it actually has two pairs of opposite sides that are parallel. And we know now that since all rectangles are parallelograms, and they also would have at least one pair of sides that are parallel, and as does a square. So all squares are trapezoids, all rectangles are trapezoids, and all parallelograms actually are trapezoids. Now, all squares are rectangles because a rectangle has four right angles and opposite sides are equal, and that certainly is true for a square. It has four right angles and opposite sides are equal. In fact, all four sides are equal. And then all rectangles are parallelograms. Again, we discussed that before, because opposite sides of a rectangle are parallel. Both pairs of opposite sides are parallel. So this is a hierarchy diagram. It's called a Venn diagram. So it's saying that squares are a subset of the rectangles, and this means subset. It's like a U, not a C. And all rectangles are a subset of parallelograms. A little sloppy there on my writing. And all parallelograms are subsets of trapezoids. So now let's take a look at a trapezoid and let's derive the formula for the area of a trapezoid. So a trapezoid, again, I have a trapezoid here. Here's a pair of opposite sides that are parallel. We'll call these bases, these opposite sides that are parallel. I'll call this B sub 1, B sub 2. So now what I'm doing is I'm going to split a diagonal. I could have gone this way, but I went this way. So I'm going to split the the trapezoid going across with a diagonal. Okay, this forms two triangles. I'll call it triangle 1 and triangle 2. And this again would be, this is base 2 and this is base 1. So now this is triangle 1, triangle 2. What I'm going to do is I'm going to rotate this triangle just to demonstrate that in fact these triangles have the same height. Remember, the area of a triangle, remember, is 1/2 times base times height. So in the case of these triangles, they both have the same height. This triangle had a base of B sub 2, and the other triangle had a base of b sub 1. So let's go back up here. Both these triangles have this height, h. We just demonstrated that at the bottom. And this can be made into two triangles. So I'll put the height here also. So the area of triangle 1, and I'll also draw the height out here so we can see that if I want to extend the base. So the area of triangle 1 is going to be specifically 1/2 times the base, which is b sub 2, times the height, which is h. The area of triangle 2 is 1/2 times b sub 1 times h. So then that leaves us with the area of the trapezoid is the sum of the two triangles. So that's the area of triangle 1 plus the area of triangle 2. The area of triangle 1 is 1/2 times b sub 2 times h, the way I've written it, plus the area of triangle 2 is 1/2 times b sub 1 times h. And you don't have to, but I'm going to rearrange this as 1/2 times b sub 1 times h. I'm just switching these around the equal sign, around the addition sign. I'm allowed to do that. 1/2 times b sub 2 times h. So now let's take this formula to the next page. So now, this is the general formula for the area of a trapezoid. So I don't need to split it into a triangle anymore. I just need to know the sum of the two bases, the value of the lengths of the two bases, and the height, and I can find the area. So the area is 1/2 b sub 1 h plus 1/2 b sub 2 h. Now, I can do what's called factoring now, common factors. Notice both of these have a common factor of 1/2 because both these terms here are multiplied by half. So I can pull a 1/2 out, and they both have an h in common also. So now 1/2 h times what gives me 1/2 b sub 1h? Well, if I take this times b sub 1, 1/2 times h times b sub 1 is equal to 1/2 b sub 1h. The order that you multiply is not important. Then 1/2 times h times what is 1/2 b sub 2h? Well, this is missing a b sub 2. So I can factor this. You can think of this as a set of parentheses here. This is a plus sign. This is going to be 1/2 h times the sum of b sub 1 plus b sub 2. And this is actually the area formula for a trapezoid. You could write it like this, but usually we write it like this. So this is 1/2 the height. We say this is the sum of the bases. And the perimeter of trapezoid, based on my diagram, is just the sum of the sides. So it's going to be a plus b sub 2 plus c, which is a length, plus b sub 1. So now let's find the area and perimeter of this particular trapezoid. So the area of a trapezoid, the area, is equal to 1/2 h times the sum of the bases. Okay, so now let's identify our parts. So this, we'll call this b sub 1, I'll call this b sub 2. These are the parallel opposite sides, so these are my two bases. I could have called this b sub 1 and this b sub 2, and by the way, b sub 2, that's pronounced b sub 2, b sub 2. This is called a subscript variable. This is b sub 1. So now let's replace our parts. Our height is, here's my h, so now I have 1/2 times, I'm replacing h with 6, I'm replacing b sub 1 with 18, and I'm replacing b sub 2 with 10. So I'm making a substitution here. H is being replaced with the particular value 6, b is being replaced with 18, and b sub 2 is being replaced with 10. Those are all equivalent. So now I'm going to do the parentheses first. 18 and 10 is 28. So now I have 1/2 times 6 times 28. I could make a half 0.5, but this is fairly easy. Half times 6, that's half of 6, is 3 times 28. So now I take 28 times 3. That's 24. Carry a 2. 2 times 3 is 6 plus 2 is 84. So my perimeter is 84. I'm sorry, my area. My area is 84 square inches. So that means inside this trapezoid, the space inside this trapezoid, I could fit 84 squares that are 1 inch by 1 inch in dimension. The perimeter is the distance around the trapezoid. And that is equal to 10, start here, 10 plus 6.7 plus 18 plus 7.8. So now I'm going to line those up. 10, 6.7. Remember, after every whole number, you must put a decimal point when you're adding so things line up properly. 18, put a decimal point behind it, and then 7.8. So now I'm going to add placeholder zeros. And now I'm going to bring the decimal point straight down. So that's 7 and 8 is 15, carry a 1. 1 and 6 is 7. 7 plus 8 and 7 is 15. 7 and 15 is 22, carry a 2. 2, 1, and 1 is 4. So that is 42.5 inches. It's just inches, not square inches. So the distance, if I had to measure around this with a tape measure, I would find the length around the figure is 42.5 inches. And this concludes the video.